Assalamu alaikum wa rahmatullahi wa barakatuh. In the last video, I forget to say to you, I forget to say that the homework will be page 120, number 223, 24, 25, 26, 29, 30, 33, 34. I solved with you 25 and 34. It is not for submitted this homework, but you must solve it in order to have a practice and to be fast in the final or in the mid. I will tell you the material in the mid will be chapter 1, the page or 6 minutes, the first video, and till we finish chapter 3. Then the mid will be in chapter 3 and the video, the first video. After that, the final will be also chapter 3, 4, 5, and 6, inshallah. But we will omit chapter 1. I will say also that section 3.3 and 3.4 are omitted. We will not study it. Also, section 3.6 also omitted. Plus, section, wait a minute. Section 3.6 also omitted. يعني I mean that section 3.3 and 3.4 and also section 3.6 will be omitted, محذوفين. يعني this means that in chapter 1 and chapter 3 we studied section 3.1, 3.2 and 3.5 only. Here I have, we will begin now the last section in this chapter, section 3.5, measures of association between two variables. I will put the homework in order not to forget it before we will begin in the chapter. Homework page 143, number 55, 56, 58, 60. I will solve with you one of these questions. I return back to say that the homework not for submitted, مش للتسليم, لكن you must solve it in order to be quickly in the exam and يعني has a practice in making tables and calculate the equations using the calculator and so on. Here, measures of association between two variables. We deal here we have studied in the previous two sections, we have studied the statistical or the methods, descriptive statistic for one sample. And we deal with one sample used to summarize the data in one variable at the time. Often, a manager or decision maker is interested in relationship between two variables. In this section, we will study covariance and correlation as descriptive measures of the relation between two variables. Notice here, we will deal always with the data that has been drawn from samples. هنتعامل مع البيانات المسحوبة من العينات وليس من المجتمعات population, since you cannot calculate covariance from a population or correlation coefficient for a population or mean for a population or variance for a population or standard deviation for a population, then they must be given. But we mention the formula, يعني احنا بنذكر بس الشكل المعادلة. Here and at the end of this section we will comment on the comments that you will say it after solving. They are not in your book or not in indirect way they are, but I will write it for you after we finish this section. The data here has been scattered on the first horizontal axis. This is horizontal. This is horizontal axis أو بنسميه x axis. Here vertical axis أو اللي بنسميه y axis. Here we put the data on the x axis and the data on the y axis. Consider each data as an order pair like this. Here you will have 2 and 50. The other 5 and 57. The other 1 and 41. Here 5 with 57, 1 with 41, and so on. 2 with 46. Here I will write it again here with consider each one has a first coordinate x and second coordinate y. This is like this. You will have here 2 of 50. First coordinate x, second coordinate y. And the second one is 5 of 57. Third one, 1 of 41. The other will be 3 of 54. The third will be 4 and 54. And so on till the end, 2 and 46. Now return back to the discussion. Here we will have in the following discussion, we consider covariance as a dispersion measure of linear association. Linear association as a descriptive measure of linear association between two variables. Covariance. Again, I will say we will calculate the sample covariance, not the population covariance, since you cannot calculate it. For a sample of size n, sample size, we have the observation as order pairs. Here you will have first coordinate, and y second coordinate. and so on. The sample covariance is defined as follows. Sample covariance has been defined as follows. The sample covariance is denoted by this SXY. SXY equals summation from I equal 1 up to n xi minus x bar multiplied by yi minus y bar divided by n minus 1. But I will give you more simplest formula, summation xi yi I from 1 up to n minus n x bar y bar divided by n minus 1. This is easiest for calculation. You can, in the book, they calculate with the first one, but in order to reduce the time for calculation, you can use this formula. But the first one is also correct. The first one is also correct. Where x bar sample mean summation I from 1 up to n xi over n. Notice also that number of data for x the same as the number of data for y. Y bar equals summation I from 1 up to n yi over n. This formula bears each xi, yi. We then sum the product. He discuss in the book the procedure for calculating the first formula. To measure the strength القوة of الpower of the linear relationship between the number of commercials X and sales volume Y in the stereo and sound equipment store problem, we see equation 3.12. Here, what is the benefit of this equation? What is the benefit of this equation? It measures the powerful of the linearity between the two samples, X and Y. Powerful of the linearity between X and Y. We have one example here, and we have number of commercials X, sales volume Y, and first of all, we make the scattering data. Scattering data means that we will have two axes. Horizontal. We have two axes, the x-axis and y-axis. We present on this graph the order pair, which means this point is 250. This point 250, this 250 here, 250 250. The other point will be 557. This is 557. The third point, 141. 141. The other 138 here, 138, and so on. You will present it here 5, for example here 5 or 63, and so on. You can make Don't put a line, but you see here there is increasing and there is no decreasing. This is like what? Like a line. It cannot be on the same line. You have from 5 points, 3 has been lying on the straight line. Then there is a positive linear relationship between x and y. There is a positive linear relationship between x and y. Slope is positive, which means there is a positive linear relationship between x and y. After calculation, they make and they find the value, it will be 11, which is positive. There is positive linear relationship, but here you cannot say it is strong or weak until we calculate sample correlation coefficient, since there is a certain comment on it and you will make the same comment on the sample covariance. I will solve one question with you, but until we finish discussing the section. Here, when the population, here, the formula for computing covariance of a population of size n is similar to the equation of 312, but for the sample, but we use different notation to indicate that we are working with entire population. Here, population covariance, sigma xy equal, this is sigma, equal summation I from 1 up to capital N, which is a population size, summation xi, which is the data from population, a population, to population, data from to population, from two populations. Here, mu x, mu y, population means for x and y, but we cannot be attention here. You cannot calculate this. You cannot calculate the population covariance. You cannot calculate it since you don't know the population mean, the population data, the population size, but you can calculate the sample covariance only. This is here another example, but you have here 10 data for x, 10 data for y. He calculate x bar, sample mean, and subtract each element from xi and calculate y bar and subtract each element from y bar. Then, but we know that from previously, from the second section, that for calculating the variance, sample variance, that the difference between total sum between the difference between each element and the sample mean will be 0. Here also 0, but multiply -1 by -1, 1, 2 by 6, 12, -2 by -10, 20, and so on. And you find that it is 11. This graph, I don't need it in order to say this is positive, this is negative. I don't need it and I don't like it. Interpretation of covariance. If the value of Sxy is positive, the points with the greatest influence on Sxy must be in quarter 1 and 3. I don't need this word, this. I don't need it. Hence, a positive value for Sxy indicates positive linear association between x and y. That is, as the value of x increases, which means that the value of y increases. If the value of xy is negative, however, the points with the greatest influence on xy are in quadrant 2 and 4. Also, I don't need this. Hence, a negative value of Sxy indicates a negative linear association between x and y. That is, as the value x increases, the value of y decreases. Finally, if the points are evenly distributed across all 4 quadrants, the value of Sxy will be close to 0. When as Sxy close to 0, which means there is no linear association between x and y. Here, from the preceding discussion, it might appear that large positive value, this will be obvious or clear when we calculate the second measure, which is sample correlation coefficient. It might appear that a large positive value for covariance indicates a strong positive linear relationship, and a large negative value indicates a strong negative linear relationship. However, one problem with using covariance as a measure of strength of a linear relationship is that the value of covariance depends on the units of measurement for x and y. Here we have, in order to solve any question of 2 samples, you must make 3 tests. The first test, graphical test, which is scatter the data on the xy plane, you will have here as x positive, y positive, which means positive slope is xy positive. Also, the slope is positive. Here you have a positive linear relationship between x and y. Here, if there is a scatter, no pattern, ليس لها شكل, we means that sy is xy approximately 0. No relationship between xy, between x and y. Here it is decreased. This means that Sxy negative. There is a negative linear relationship between x and y since the slope is negative. There is a negative linear relationship between x and y. As x increases, y decreases. X increases, y decreases, and so on. It will be obvious when we study the correlation coefficient. A measure at the last thing before we end this video, we will have a measure of a relationship sorry, between two variables that is not affected by units of measure is called correlation coefficient. We will continue in the next video inshallah, and talking about correlation coefficient, and after that we will solve one question on this material. Thank you very much.